I'm Professor Pi. Welcome to my daily mathematical adventures. Hey, don't forget me. I'm Cowboy Rufus. I'm your favorite student. Let me tell you how we teach the algebra. On Thursday, all of my students virtually and all of my students in class could do one-step algebra equations. So my goal today is to get every single equation to look like Thursday's equations. That is, I will get my two-step equations look like one-step equations, and then everybody can solve them because everybody could do that Thursday. Now, the objective is to interpret the contextual meaning individual terms of factors given by a problem that utilizes formulas and expressions. We are going to represent constraints and equations by inequalities in a system of equations or inequalities and interpret the data points as the solution. Do you want that in English? We're going to have equations. We're going to have equations that give us data and formulas. So the I can statement doesn't have all that math stuff up there. It says I can solve two-step equations. At the end of this lesson, if you can solve some two-step equations, we're doing pretty well. Here's the most important theorem in algebra. Yesterday, we talked about the big kid on a teeter-totter. He can keep you up there for a whole period. 30 minutes of recess, and all you've done is gone up once. It's not fun that way. It's teeter-totter. We're going to balance the equation. That is, if we add 7 on this side, we must add 7 on this side. Add 14 on this side, we add 14 on this side. We have to keep our equation balanced because this teeter-totter is so much more fun than having the big kid hold you up in the air. The other thing I need to worry about is it's a two-step equation, so I got to worry about which step do I step first. Take a look at this shoe, and we'll figure out the two-step equation. How did this person get dressed? Did they put their shoe on and then their sock on? I look around the room. Most of you managed to get your socks inside your shoes. In fact, all of you who are wearing socks got them inside the shoe. Now, when I come home, one of the first things I do is kick off my shoes. What's the first thing I do is kick off my shoes. Why don't I kick off my socks first? Can't take my sock off unless you got a sharp knife or scissors. You can't take your sock off without taking your shoe off first. Now, the order of operations. Please eat my dead sandwich. Some of you heard of the other one. Please excuse my dear Aunt Sally. What this means is, what do we do first? We do parentheses first. Then we do exponents. We do exponents. Then we multiply and divide. And then the last thing we do is we add or subtract. Now let's go back to this cute little shoe up here. How do you think they got dressed this morning? I think they put on a sock then a shoe. Sock then a shoe. How are we going to take it off? We're going to take it off backwards. Shoe then sock. Shoe then sock. Since we've decided that that's backwards, look at my please eat my dead ant sandwich. What are we going to undo first? We're going to undo addition and subtraction. How are we going to do that? We're either going to add or subtract. Then we're going to undo multiplication. We're going to multiply or divide after we add or subtract because we're going to take our shoe off, then our sock off. So the order of operations here is backwards. I don't think any problems today have exponents, but after we get rid of multiplication and division, we'll get rid of exponents. How do you get rid of an x squared? You take the square root of both sides. Leave that for a few more chapters down the road. And if we have any exponents, after we get rid of the exponents, we're going to get the parentheses, because they're done first, then we're going to do them last. Here are my examples. You ask yourself, what are we doing to x? Every day in algebra, we're going to take a look at x. We're going to take a look at the variable. Sometimes it's a, b, c, y, j, or w. Your book likes L and K. On the test, I like X. What are we doing to X right here? In English, we are multiplying by 5 and adding 7. Multiply by 5, add 7. So let's undo, add 7. What do you do to undo 7? You subtract 7, both sides. I did that right here. Simplify it, and it comes out 5x equal 10. We don't want 5x. We want 1x. We always want one variable. I don't care what 5 is. So how do we get rid of the 5? We're going to divide by 5 on both sides. And you could solve that problem Thursday. So we took this problem and we got rid of the plus 7, and then it looks exactly like what we did last week. Here's my next example. Take a look at my equation and tell me in English, what are we doing to x? We are multiplying it by 5 and then subtracting 7. Two-step equations. We can multiply and add. We can multiply and subtract. Here, we're going to add 7 to both sides. We get x equal 30. We should get 5x equal 30. You can't leave that 5 out, guys. Now, so if 5x equal 30, 1x equal 6. Here's an example. What are we doing to x? We're dividing it by 7, adding 9. If you can tell me that, you can tell me how to undo it. Multiply by 7. You know the opposite of that. It's divide by 7, but we're not going to do it first. We're going to do it second. What's the opposite of add 9? What happened here? What did I just say? I said you couldn't divide first, right? What are we going to do first? We're going to subtract 9 both sides. Once again, you can't take off your socks without taking off your shoes. So let's fix this. Now, we got 11. We got to subtract 9 on both sides, right? If we don't subtract 9 on both sides, you get the really big kid holding you on the air in the teeter-totter. No fun. So this can't be right. So what do we get now? What do we got now? We got x divided by 7 is equal to 2. Now, why did we have to subtract 9 before we multiply by 7? You can't do it that way, right? I just wanted to see if you were trying to take off your socks without taking off your shoes. We can't do it that way. So we subtract 9 from both sides. That's what we did up here. Let me just move that up there. We subtract 9 from both sides. Then we got that. Now, we need to figure out how to get rid of divide by 7. So let's multiply by 7. One side or both, we want both.
High students, your principal speaking. Staff members, if you are in the building, you guys will.
We multiply both sides by 7. 7x divided by 7 is equal to Don't ask me where that extra X came from. If you're in class, you should have. 2 times 7. And 2 times 7 will not get me 86. Once again, I got 86 the wrong way. I took off my socks, then I took off my shoes. If you don't do the order of operation backwards, your answer comes out nowhere near mine. I have one more example here. Do I have to do it? But I'm going to divide by 5 and then subtract 7. How are we going to undo that? We're going to add 7 to both sides. We're going to multiply by 5 both sides. I hope I don't have to do that one. Could you multiply and then divide? What happens when you multiply then divide? Let's try that. 7/8 times X. How would you undo that? Well, what's the opposite of divide by 8? That would be multiply by 8. What's the opposite of multiply by 7? That would be divide by 7. But let's just do it the easy way. Flip that thing upside down and multiply both sides. 8 divided by 7 now. Do the 7s cancel out? Yes, they do. Do the 8s cancel out? Yes, one on the top, one on the bottom. They cancel out. What's left over here? Just an X. And then you take whatever else you had over here. Let's say it was originally X, 7/8 X equal 5. We multiply by that on both sides. What do we get? We get X equal 5 times 7. We get 5, not writing, 5 times 7 divided by 8. And yes, it doesn't come out a whole number. 35 divided by 8 is not a whole number, but most of the problems in our book are not whole numbers. Thank you for seeing this with Professor Pi. I'm glad you're excited about math. Okay. Maybe you're not as excited as Professor Pi. If you hate math and still learn it, I'm okay with that. But thanks for watching another Professor Pi video. Yeah, y'all come back tomorrow. Cowboy Rufus and Professor Pi will teach you something new.